All right, Math 1, this is lesson 3.1, solving systems by graphing. Our con skills are going to be from Unit 6. The SOE stands for Systems of Equations, and this chapter is related to skills 1, 2, and 4 from that unit in Khan Academy. You'll notice the setup for these notes is a little bit different. We have a column here where you can write your questions. I recommend you do that no matter how the notes are set up. As you're watching this video and taking notes, if something doesn't make sense, it's a good idea to write your question on the side right away so that at the end of the video, when I ask you to type a question, you already have an answer prepared. Okay, so our first blank is a system of linear equations, or simply a linear system, consists of two or more linear equations in the same variables. And here's an example. So you'll notice we have one equation here and a second equation. And usually to show that we have a system, we put this blue symbol here. That's a brace. There's parentheses. You know what those look like? Brackets look like parentheses, but with corners. And braces look like that. So we have an open brace there to show that we have a system of equations. And this is a system specifically of linear equations, because if you remember from chapter 2, these two equations are linear equations in standard form. Remember the ax plus by equals c form, right? So we have two linear equations that make a system. The second blank should be solution set. The solution set is the x and y values that satisfy each equation. One way to find the solution set is by graphing both equations and finding where they intersect. So I'm taking this word set for granted. It has a more precise mathematical definition that I'm just going to skip for now. The main thing you need to know is that the solution set is the collection of all xy pairs that make both equations true. Okay? So at least for this lesson, the solution set will just have 1 point in it, one xy pair. But there are other cases where the solution set has, let's just say it doesn't have one solution. It might have something different than just one solution. And we'll get into that in a later lesson. But for now, the solution set is really just going to be 1 point. Okay, so we have steps for solving linear systems here. This is a good graphic, but we do need to change one thing. I want you to cross out this stuff. This is from something else. For us, when we write both equations in slope-intercept form and graph it, if you need help remembering how to do that, you should look at chapter 2. The last chapter we covered, remember slope-intercept form. We talk a lot about that in chapter 2 and how to graph from slope-intercept form. But once you graph, you'll need to find the coordinates of the point of intersection. What I mean by that is, if on our graph we'll have, we'll have one line. Let's say it looks like this, and if we graph the second line that looks like, I don't know, maybe that, then the point of intersection is that point right there where they cross, and that's going to be our solution. So we need to find out, well, what are the coordinates of that point? That'll be our solution. Step 3, we need to check the coordinates by substituting into the original equation. So we would take these numbers, this xy pair, and we'd plug those in to both equations to make sure that they actually are solutions, that we get true statements. And that check is super important. It's one of the reasons why I like chapter 3 so much, is because you can always check to see if your answer is correct. And really, why would you not want to take that step and find that out? So for all of these problems, it's really important. You need to be checking your answer to make sure that it's correct. If it's not correct, then you know you did some calculation wrong, and you can go back and fix it, which is a luxury we don't always have in math, right? So Finally, in step 4, we write our solution as a coordinate point. So your solution should always look like x comma y. It should be some number and some other number, right? That's what we're looking for. Okay, so let's try this one together. I know this is a lot of words. Let's see what it means. So we have two equations, and our first equation that I highlighted in blue, we can see its slope and its y-intercept already, so we're ready to graph. The y-intercept of 1 means that the point goes through 1 on the y-axis. We can put our first point there. And then the slope of 2/3 means that if we go up 2 and to the right 3, we'll find another point on our line. And then we can draw our line that goes through those points, something like that. And that's our equation, y equals 2/3 x plus 1. And then we're going to do the same thing with the second point, or the second equation, excuse me. Y equals 3. There's no slope. The slope is 0 there. Remember, y equals a constant number. That's going to be a horizontal line through that number, 3, on the y-axis. So we're going to draw our line there. This is the line y equals 3. And then our next step was to find the coordinates of the point of intersection. That's this point right here. Oops. So the coordinates of that point where the two lines cross, looks like that's 3, 3. After that, we want to check the coordinates by substituting into the original equations. So we're going to plug in 3 for x and 3 for y into these equations and see if we get true statements. So we plug in 3 for x and 3 for y here and here. We do get a true statement. 3 equals 2 plus 1. That's true. So this point, 3, 3, is definitely a solution for the first equation, the first line that we graphed in blue. And then if we plug in 3 for x and 3 for y, well, really just y, into the second equation, of course that's true. 3 equals 3, right? So that point is also a solution to the green equation. So we checked our work. Our answer is correct because these are true. And then our solution, we just want to write as an ordered pair. That's step 4. And that's it. We're done. We found a solution to this system by graphing. All right, let's try another one. Here's number 1 here. Again, these ones are really nice because they're already in y equals mx plus b form, or slope-intercept form. So our red equation is already graphed because I started at 4, our y-intercept, and then our slope is 8 over 3. And I just want to point out that when the slope, let's zoom in a bit more. When the slope is 8 over 3, I don't have room to go up 8 and over 3 for this graph. So instead, you have to remember that negative 8 over negative 3, a negative divided by a negative, is still positive. So that's how I got this point here. Is I went down 8 and over 3 to get the second point. I'm going to erase that, though. I don't want our graph to get too cluttered. We can graph the blue equation the same way. So we have our y-intercept of negative 3, and our slope is 1/3. So we can go up 1 and over 3, draw our line. Now that we've graphed, we finished step 1. Step 2 is to find that point of intersection, which looks like negative 3, negative 4. And then our next step would be to check our work. So we plug in negative 3 for x and negative 4 for y into this equation. And when we do, we find that negative 4 equals negative 4. That's true. So it's a solution for the red equation, and it's also a solution for the blue equation because we still get another true statement when we plug these values in for x and y in the blue equation. So since it's a solution for both equations, our work was done correctly. Our solution is -3, -4. Go ahead and try number 2 on your own. Pause the video and then come back and check your work. Okay, so we have a green equation and a purple equation. I graphed them both, found where they cross. That's the point of intersection. Plug these values in and we get true statements. So that checks our work. We know our answer is truly a solution. So our solution is 3, 2. Now we have a little bit more work for these next two. Notice that in number 1 and number 2, they were already in y equals mx plus b form, so they were ready to graph. In problem 3 and problem 4, you have to remember how to turn it from other forms back into slope-intercept form. We did a lot of that last chapter in chapter 2. Let's start, we'll do number 3 together. Neither of them are in slope-intercept form, so we have to solve for y, get y by itself. And I did that right here. So I took our equation and I chose to rewrite it the other way. It's the same thing I just wrote, -x plus 6y on the left instead of the right. After that, I added 9x to both sides so that we had a positive 9x on the right. Now y is close to being by itself, but we have to divide by 6. So if I divide both sides of this equation by 6, we'll get y on the left, and then we can divide each term by 6 on the right side. And that 9/6 reduces to 3/2. And then 24 divided by 6, that's a whole number, that's 4. So all that work, now we have our blue equation in slope-intercept form, so we can graph it. We're going to do the same thing for the green equation now. So this is how I would recommend you get it in slope-intercept form. Get y by itself, and then you'll be able to tell what the slope and y-intercept are. And so this is our same system, just written, instead of written in this form, written in mx plus b form. Now we can graph them. So our, that erased. Our first equation, our blue equation, has a starting point of 4, and it has a slope of 3/2, so I went down 3 into the left 2 to graph our line. Our second equation has a starting point of -3, and then it has a slope of -1/4. So I went up 4, but to the left, or up 1, but to the left 4, like that. Or you could go down 1 and over 4 and put the point there too. Either way, we'll find our two lines, and that point where they cross is -4, -2. Lastly, we need to check our work. So we plug -4 and -2 into the equations. Now, if you plug them into these, I guess I won't mark you down as long as your calculations are correct. But keep in mind, we might have made a mistake in these calculations. So my recommendation for you is that you take your ordered pair and always plug it into the original system that you were given. Even though it might not look as pretty, this isn't the equations you would use to graph. That's probably the best way to check your work. So I plugged in -4 for x and 2 for y into the original blue equation here, and then also into the original green equation here. And then from there, you know how to follow the order of operations. We would multiply, be careful of those minus signs, and then combine your like terms, add or subtract as needed, and both of them are true. So that means this answer is the correct solution to our system. All right. Try this last problem on your own, and that'll be the end of our video. Come back and check your work when you're done. Okay, neither equation was already ready to graph. They weren't in mx plus b form, so we get them in mx plus b form. We can then use those to graph. We have our red line and our purple line, and they cross at 1, 3. And then again, instead of plugging this into the system you found, because that slope-intercept form is nicer to use when we're graphing, I recommend you take that and plug it into the system that we were originally given. And that's what I did here. We get true statements, so 1, 3 is our answer. All right, that's it for 3.1. As always, type a question at the end of the video or make up your own question, and I will see you all in class.